And so this is question 2 on the 2022 AB Calc BC3 response, and is a particle is moving along curve in the xy plane, so its position is x of t comma y of t at time t greater than 0. The particle moves in such a way that dx dt equals the square root of 1 plus t squared, and dy over dt equals the ln of 2 plus t squared. At time t equals 4, the particle is at point 1 comma 5. So part A. Find the slope of the line tangent to the path of the particle at time t equals 4. So we know that dy over dx equals dy over dt over dx over dt. And it says at time t equals 4, so we want to evaluate these at t equals 4. And this will get us the ln of 2 plus 4 squared over the square root of 1 plus 4 squared. And this is a calculated question, so this comes out to be 0.701, and that is the slope of the line tangent to the path of the particle at time t equals 4. Now part B says to find the speed of the particle at time t equals 4 and find the acceleration vector of the particle at time t equals 4. So we know that speed equals the square root of dx over dt squared plus dy over dt squared, and it's again at time t equals 4. So we are evaluating the square root of 1 plus 4 squared plus ln of 2 plus 4 squared, and this comes out to be 5.305, and that is the and so then the acceleration vector is going to be d squared x over dt squared evaluated at t equals 4, comma d squared y over dt squared evaluated at t equals 4. And since this is a calculated problem, we can just use the derivative function on the calculator. And we get 0.970, comma 0.444 as our acceleration vector. Part C says to find the y-coordinate of the particle's position at time t equals 6. And at the beginning of the problem, we get the initial condition that at time t equals 4, the particle is at the point 1 comma 5, so we know that y of 4 equals 5. And because of the fundamental theorem of calculus, we know that y of 6 equals y of 4 plus the integral from 4 to 6 of dy over dt equals 5 plus 6.571, and that gets you 11.571 as the y-coordinate of the particle's position at time t equals 6. Part D asks for the total distance the particle travels along the curve from time t equals 4 to time t equals 6, and we know the formula for arc length is the integral from a to b of the square root of dx over dt squared plus dy over dt squared dt. And for this particular problem here, it is the integral from 4 to 6 of the square root of square root of 1 plus t squared plus ln of 2 plus t squared dt, and this comes out to be 12.163. And this problem did not give any units, so none of my answers had units in them.